Hello and welcome back. So today we'll be continuing the lesson electricity. If you have not watched the first part, I request you to please go back to my channel, or you can click on the link given in the description box and watch it, and then watch this one. So the people who have already watched the first part, let's continue with the second one. So let us understand the concept of Ohm's law. Let's take an example of a circuit that has been taken here, and it consists of a nichrome wire, say 0.5 meter length, an ammeter to measure the current, a voltmeter, and 4 cells of 0.4 volt each. And nichrome is an alloy of nickel, chromium, manganese, and iron metals. So here I will be using only one cell as the source in the circuit. So note the reading in the ammeter I for the current and reading of the voltmeter V for the potential difference across the nichrome wire. Now, as I said, I have taken one cell and the volt is 0.4. So imagine that I got the current reading in the ammeter is 0.1. Now in case I take two cells in the circuit, then volt is 0.8, then the ammeter reading will be 0.2. Let's just say I got 0.2. Again I'll repeat the same steps by using 3 cells. That is, volt will be 1.2 because I'm taking 3 cells, each containing 0.4 volt and reading 0.3 of I. Again I repeat it for 4 cells and the ratings are given here. You can see that. Now in case I have to draw this in a graph or plot it in a graph, the nature of the graph is somewhat like this. Now in this graph you can observe that it is a straight line that passes through the origin of the graph. So V divided by I, if you calculate, it will be in a constant ratio. So in the year 1827, a German physicist, George Simon Ohm, found out the relationship between the current I flowing in a metallic wire and the potential difference across its terminals. So he stated the Ohm's law, and that statement is that the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. In other words, you can say V is directly proportional to I, or V divided by I is equal to a constant value, and that constant value can be represented by the letter R, or you can say V equal to I into R. Now in this equation, R, which is a constant for the given metallic wire at a given temperature, it is called the resistance. It is the property of a conductor to resist the flow of charges through it, and its SI unit is ohm, and it is represented by the Greek letter omega. If the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R, that is R is equal to V divided by I. So you get it as 1 ohm, which is equal to 1 volt divided by 1 ampere. That defines 1 ohm. From the same equation we can get I equal to V divided by R. So the current through a resistor is inversely proportional to its resistance. If the resistance is doubled, the current gets halved. A component used to regulate current without changing the voltage source is called variable resistance in an electric circuit. A device called rheostat is often used to change the resistance in the circuit. As we know that motion of electrons in an electric circuit, it constitutes an electric current. The electrons, however, are not completely free to move within a conductor. They are restrained by the attraction of the atoms among which they move. So, motion of electrons through a conductor is retarded by its resistance. Now, a component of a given size that offers a low resistance is a good conductor. A conductor having some appreciable resistance is called a resistor, and a component of identical size that offers a higher resistance is a poor conductor, and an insulator of the same size offers even higher resistance. The resistance of a conductor, it depends on its length, on its area of cross section, and on the nature of its material. So, resistance of a uniform metallic conductor is directly proportional to its length and inversely proportional to the area of the cross section. That is, in terms, R is directly proportional to L, and also R is inversely proportional to 1 by A. A is the area of the cross section. Now, if you combine these two equations, we get R proportional to L by A, and R is equal to rho L divided by A. Now, in this formula, the term rho is a constant of proportionality and is called the electrical resistivity of the material of the conductor. The SI unit of resistivity is omega meter. It is a characteristic property of the material. Here you can observe the electrical resistivity of some substances. The metals and alloys have very low resistivity in the range of 10 to the power minus 8 omega meter to 10 to the power minus 6 omega meter. They are good conductors of electricity. Insulators like rubber and glass have resistivity of the order 10 to the power 12 to 10 to the power 17 omega meter. Both the resistance and resistivity of a material vary with temperature. And you must know that alloys do not oxidize or burn readily at higher temperatures. For this reason, they are commonly used in electrical heating devices like electric iron, toasters, etc. Tungsten is used almost exclusively for filaments of electric bulbs, whereas copper and aluminium are generally used for electrical transmission lines. Now let us solve some problems. First one, how much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 omega? Now in this question, you can see that V, which is equal to 220 volt, and R resistance is 1200 omega is already given. So if you put this in the equation, so I equal to V divided by R, we get the answer as 0.18 ampere. Next question, how much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 omega? Now in this again you get the value V equal to 220 volt and R is 100 omega. Now again if you substitute this in the same equation, I equal to V divided by R, we get I, and that is 2.2 ampere. The potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? V, potential difference 60 volt, and current I equal to 4 ampere is already given. Now if you apply Ohm's law here, R equal to V divided by I, which gives you R, and 60 divided by 4 is 15 omega. Now when the potential difference is increased to 120 volt, so I equal to V by R, so it is 120 divided by 15. So you get I as 8 ampere. Resistance of a metal wire of length 1 meter is 26 omega at 20 degree Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? predict the material of the wire. So here it's simple. R is given, which is 26 omega. Diameter is 0.3 millimeter. So convert it into meter. So you get 3 into 10 to the power minus 4 meter. And length L is 1 meter. So if you put this in the equation, rho is equal to RA divided by L. Now area you know, so if you substitute that, you get rho equal to R into pi into d square divided by 4L. So substituting the values, we get the resistivity as 1.84 into 10 to the power minus 6 omega. And if you have seen the chart that was provided before, in that chart if you go through, this value belongs to manganese. That's the resistivity of manganese. So the material used here is manganese. A wire of given material having length L and area of cross section A has a resistance of 4 omega. What would be the resistance of another wire of the same material having length L divided by 2 and area of cross section 2A? So for the first wire, R is equal to rho into L divided by A. That's the formula, which is equal to 4 omega, already given. And for the second wire, it is rho into L by 2 divided by 2A. That will be the resistance. It's given in the question. Now if you substitute, you get 1 by 4 into rho into L by A. So R2, the resistance of second wire, is equal to 1 by 4 into the resistance of the first wire. So R2 is 1 omega. I do hope you have understood this chapter till here. In case you have any doubts, you can please comment below, and the next part will be continued in the next video. Until then, do subscribe to my channel and keep watching for more videos. Thank you and have a good day.